This is Miss Sebastian, and we're going to look at the probability unit test. Each letter of the English alphabet is written on a scrap of paper and put into a hat. The probability of getting an S is 1 out of 26. What type of probability is illustrated and why? So you've got theoretical probability, and that probability is based just on the number of outcomes. And then you have experimental probability, and that is based on experiments or real life. So this one, if you've got 26 letters in the English language and you want to know the probability of getting an S, well, that's a 1 out of 26 chance. That would be the theoretical probability because it's based on the number of outcomes, not by what you actually get if you draw these out of a bag. The expected result of tossing a coin 20 times and the probability of getting heads is 10 out of 20. So we need to know if this is experimental or theoretical probability. So remember that theoretical is the result based on the number of possible outcomes. So we can go ahead and cross out this one. It's not found by repeating an experiment. That's experimental. So these two, experimental, is based on repeating an experiment, not the number of outcomes. So those two are the only ones that state them correctly. But if we look at the probability of tossing a coin 20 times, the only way you'd get 10 out of 20 for it to be perfect probability, and every time you toss it in the air, one time you get heads, one time you get tails, one time you get heads, one time you get tails, only happens theoretically. Okay, experimental would be more like 9 out of 20 or even 3 out of 20. Okay, it can vary every time. It should come as close as possible to theoretical as you toss it more and more times, but it is hardly ever the exact probability listed. A number cube is rolled 200 times. The number 5 comes up 46 times. What is the experimental probability of rolling a 5? So experimental probability is based on the experiment. So during the experiment, you got 46 number 5s out of 200 times that you rolled it. So we're going to simplify that. 46 and 200 are both divisible by 2. So I'm going to divide both the top and the bottom by 2. And I do get 23 100ths. And then we're looking for the theoretical probability of rolling a 5. Well, a number cube, that's a die or a dice. And that has 6 sides, one of which is a 5. So you have a 1 out of 6 chance of getting a 5, and that's your theoretical probability. That's what should happen in theory. The 23 out of 100 is your experimental probability, or what actually happened. What happens based on the experiment. A spinner is divided into 11 equal sections numbered 0 to 10. You spin the spinner once. What is the probability of getting a multiple of 3? So on this one, 0 is considered a multiple of 3 because 0 times 3 is 3. So I'm going to write out all of the numbers between 0 and 10. And then I'm going to underline the multiples of 3. I've got 0, I have 3, I have 6, and I have 9. So 4 of those are multiples of 10. Multiples of 3. And we have 11 sections. So I've got a 4 out of 11 chances. So 4 of those are multiples of 3 out of 11 total sections that the spinner could land would be my probability of getting a multiple of 3. So 4 out of 11. A bag contains 7 green marbles and 12 white marbles. You select a marble at random. What are the odds in favor of picking a white marble? Now, this one says odds. It doesn't say probability. So odds are a little different because what they say is, I want to know the odds or the ratio of getting this marble. So I'm looking for the white marble. It comes first. Whatever you're in favor of, that is what comes first in your ratio. So I have 12 white marbles. They usually write it with this colon there. 12 white to 7 green. So 12 to 7. So you have 12 chances of getting a white marble, 7 chances of getting a green marble. Food Express is running a special promotion in which customers can win a free gallon of milk with their food purchase if there is a star on their receipt. So far, 174 of the first 256 customers have not received a star on their receipt. What is the experimental probability of winning a free gallon of milk? So the 174 have not won one yet. So what we're going to do is we're going to figure out how many have already gotten a free gallon of milk by doing this subtraction. So 6 minus 4 is 2. 5 minus 7 I can't do, so I've got to borrow from that 2. That makes this a 15. 15 minus 7 is 8. 1 minus 1 is 0. So 82 have already gotten a free gallon of milk. So I'll put free. So 82 out of the total number of customers there, 256. And I am going to simplify that. I know both of these are divisible by 2. So I get 41 and 128. So the odds of winning a free gallon of milk, the probability of winning a free gallon of milk is 41 out of 128. A bag contains 15 green marbles, 3 red marbles, 7 orange marbles, 6 brown marbles, and 8 blue marbles. You choose a marble, replace it, and then choose again. So what is the probability of getting blue and then green? So first we need to know how many total marbles we have. We have 15 green, 3 red, 7 orange, 6 brown, and 8 blue. So I'm going to add these up. 5 plus 3 is 8, plus 7 is 15, plus 6 is 21, plus 8 is 29. So I'm carrying that 2. And I do get 39 there. So out of 39, I need to draw a blue. So I look up here in my problem and see how many blue marbles there were. And there were 8. Then I'll have to find the probability of getting a green. We are replacing it, so I still have 39 marbles to draw from. and there are 15 green. Now, when you have the probability of two different things, and you want to know what's the probability of getting something and then something else, you have to multiply those. So I'm going to multiply across the top 8 times 15, and I get 120. And then 39 times 39 is 1,521. I see both of these are divisible by 3. So I'm going to simplify just a little. So I get 40 and 507. So the probability of getting blue and then green is 40 out of 507. Each of 2 urns contains green balls and red balls. Urn 1 contains 12 green balls and 5 red balls. Urn 2 contains 6 green balls and 8 red balls. If a ball is drawn from each urn, what is the probability of getting red and then red? So that means out of the first urn, there are 12 and 5. So 12 plus 5 is 17. And we're trying to get a red out of those. So there are 5 in the first urn. Going to do the same thing. We're going to multiply these two probabilities because we're looking for a combination there. And this time we've got 6 green balls and 8 red balls. That's 14 total. And there are 8 red balls, so 8 chances to get red. So we're going to multiply across. 8 times 5 is 40. And 17 times 14 gives me 238. I do see that these are both divisible by 2, so we do want to simplify. And we get 20 out of 119. So the chances of getting a red ball from the first urn and a red ball from the second urn are 20 out of 119. If you spin the spinner below twice, what is the probability of getting S and then a vowel? So I see there are 1, 2, 3, 4, 5, 6 spots on this spinner. Because we're looking at 2 different probabilities that we want to know what the probability is of them happening one after another. I see there is 1 S up there. So I've got 1 out of 6 chance of getting an S. And then I look for vowels and I see A and U. So there's a 2 out of 6 chance of getting a vowel. So now I'm just going to multiply these because those are 2 independent events. And I want to find the probability of both of those happening. So 1 times 2 is 2. 6 times 6 is 36. And then I'm going to simplify by dividing both of those by 2 because that is their greatest common factor. So I do get 1 over 18. So the probability of getting an S and then getting a vowel is 1 out of 18. You have 5 $1 bills, 1 $5 bill, 6 $10 bills, and 4 $20 bills in your wallet. You select a bill at random without replacing the bill. You choose a second bill. So what is the probability of getting a $10 bill and then a $5 bill? So I see we've got 5, 1, 6, and 4 bills. So we've got 6 and 4. So if I add these up, 5 plus 1 is 6, plus 6 is 12, plus 4 is 16. So the first time I draw a bill out of the wallet, there are 16 bills in there to choose from, 6 of which are $10 bills. So I've got a 6 out of 16 chance of getting a $10 bill. The second time I bring it out, because I did not replace it, it says without replacing the bill, I don't have 16 bills anymore. I only have 15. And then I'm trying to get a $5 bill. There is only one $5 bill here. So I've got a 1 out of 15 chance of choosing that. So now all I'm going to do is simplify by multiplying. So 6 times 1 is 6. And 16 times 15 is 240. I see both of these are divisible by 6. And I do get 1 out of 40. So I've got a 1 out of 40 chance of getting a $10 bill and then not replacing it and getting a $5 bill. A basket contains the following pieces of fruit: 2 apples, 3 oranges, 4 bananas, 3 pears, and 7 peaches. Jack picks a fruit at random and does not replace it. Then Bethany picks a fruit at random. What is the probability that Jack gets a peach and Bethany gets a banana? So the first thing we need to do is find out how many total pieces of fruit there were. So 2 apples, 3 oranges, 4 bananas, 3 pears, and 7 peaches. 2 plus 3 is 5, plus 4 is 9, plus 3 is 12, plus 7 is 19. Okay, so Jack picks a fruit first, and Jack wants a peach. Well, there are 7 peaches. And then he doesn't replace it, so that means there are not 19 pieces of fruit yet. There are only 18 left. And Bethany wanted a banana. So there are 4 bananas. So I am going to multiply across. 7 times 4 is 28. 19 times 18 is 342. I do see both of these are divisible by 2, so I can simplify them. I get 14 out of a 171 chance of getting a peach for Jack and a banana for Bethany. The probability of a certain baseball player hitting a foul is 1 out of 3. How many foul balls would you expect her to hit after 90 swings? So if you have 1 foul out of every 3 balls hit, and you're looking for how many they would hit out of 90, there's 3 ways you can do this one. So the first one is you could cross multiply, and you could say 90 times 1 equals 3 times x. And we could isolate the variable by dividing both sides by 3. On the right, they cancel out and make 1. 90 divided by 3 equals 30. So we know the answer is 30, but how else could we do it? Well, we could say 3 times 30 gives me 90. So I'd multiply the top by 30 as well and get that 1 times 30 is 30. You could also say 1/3 times 90. 1/3 times 90 is also 30. So out of 90 swings, we would expect 30 fouls. A true-false test has 14 questions. What is the probability of guessing the correct answer to all of the questions? So, on the first question, you have a 1 out of 2 possibility of getting it correct. On the second question, you have a 1 out of 2 possibility. Same with the third, and the fourth, and the fifth, and the sixth, and the seventh. Keep going all the way up to 14. Okay, so you've got a 1 out of 2 chance every single time that you try these questions. So you'll multiply across the top. And you get 1. And then multiply the 2 14 times. And you do get 16,384. And that is the same as doing 2 raised to the 14th power, because you're multiplying 2 by itself 14 times. So because every single question you have a 1 out of 2 chance of getting it correct, the probability of you guessing those is not real good. So that just tells us to make sure you study for that test. Okay, simplify 6 factorial. So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So if I multiply 6 times 5, I get 30. Times 4, I get 120. Times 3, I'm just bringing them down one at a time. I get 360. Times 2, I get 720. Times 1, I do get 720. So 6 factorial is 720. Simplify 8 permutations of 3. So I always start with this number here, which is 8. And I'm going to multiply times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 8 factorial on the top. You divide that. This is n, this is r. Okay, so I'm going to divide that by n minus r factorial. This is the formula for this. Okay, I'm going to show you a simpler way to do it here in just a second. So n minus r, so 8 minus 3 factorial. So on the bottom, I would have 8 minus 3 is 5. So 5 times 4 times 3 times 2 times 1. So if you notice, the 5's cancel, 4's cancel, 3's, 2's, and 1's. So all you're left with is 8 times 7 times 6. Now here's the easier way than writing all of that out. Is I start with this number here. I start with 8. And I go down 3 digits. So 8, that's 1. 7, that's 2. And 6. That's the same thing. So we're going to multiply those out. 8 times 7 times 6 gives me 336. And that's my answer there. 8 permutations of 3 is 336. Now if I have another one, 7 permutations of 5. Okay, I would do 7, bring that number down, and count down 5 times. So 7, 6, that's 2, 3, 4, 5. I would multiply those out and I would get my answer. So 7 times 6 times 5 times 4 times 3 would give me 2,520. You could do that with any of them. Always start with your number on the left, the N, and count down however many positions are in the right or the R position. Now combinations are very similar to permutations with one added step. So you're going to bring down the 13, bring down that number in the N position, and you're going to count down however many numbers are in the R position. So I'm going to count down 4. So this means if I have 13 different items and I want to make combinations of 4, and order does not matter here, I'm going to say, well, that'll be 13 times 12 times 11 times 10. So however many items I'm going to have in my set, that's 4. Out of the 13, that's how many numbers I count down. So that's our first step. Then the added step with combinations is that we take this 4 and we're going to do the 4 factorial on the bottom. 4 times 3 times 2 times 1. So on the top, you have 13 times 12 times 11 times 10. And you do get 17,160. And then you've got 4 times 3 times 2 times 1 on the bottom, and that's 24. Then you just need to simplify. 17,160 divided by 24. And that's 715. So when order doesn't matter, you can have 715 different combinations. You and 4 friends go to a concert, and how many different ways can you sit in the assigned seats? So there are 5 of you total. So you're going to do 5 factorial. And that means 5 times 4 times 3 times 2 times 1. That's going to be 120 different ways that you can sit in those seats. Now, make sure on this one that you count you, because you're still a person. You and 4 friends. So that means 1 plus 4, and that's how we got 5. You own 8 pairs of jeans and want to take 3 of them with you. So I know our numbers here are 8 and 3. In how many ways can you choose 3 pairs of jeans? So on this one, order doesn't matter. So it's going to be a combination here. We're going to start with 8. And we're going to go down 3 times. So 8 times 7 times 6. That's 1, 2, 3 numbers. And then The bottom of this fraction is the number of the box, the number of items you are choosing, factorial. So 3 times 2 times 1. So on this, I'm going to multiply the top. 8 times 7 times 6. That's 336. And then 3 times 2 times 1 is 6. So when I simplify, that gives me 56 different ways that we can choose 3 pairs of jeans.